All right, so here you go. When I asked you, is there a difference? And the answer is no. And you might be wondering, how come? So let's look at that. Okay, we have the p-value calculated for the f-test. The f-test, I'm comparing how much variation there was in this group versus how much variation was in this group. And I don't care if they both have a lot of variation, if they both have very little variation. What I care is there one group that has a lot of variation and then another group that has very little variation? So this is what the f-test is asking. And then it says it's 0.97. So then what this is saying is that there's a 97% chance that, so that's the probability, that the difference I saw in the variation here and here is randomness. So that's what that number means. And then what does that mean when I want to say, oh, this was statistically different or statistically significant? What do scientists mean? That means that they took the p-value that was calculated, they compared against a critical p-value, which somebody determined. And if they want to be even more impressive, they might even say what the p-value, calculated p-value was. But people don't pay attention to those details. They just pay attention to, so was there statistical difference or not? So we're like, well, if you consider the 5% as the critical p-value, then 0.97 is, actually I'm going to write this here, 0.97, it's greater than 0.05, right? So I'm comparing my calculated with my my critical. And remember, up here, if the calculated is greater than or equal to the critical p-value, there's no statistical difference. So no significant, okay, pretend I wrote it right, significant difference between variances. All right, so it's I start the lab with this because this is very important that you get to these statistics, because you're going to learn again, you're going to forget again. But if you stay in science, then this is just some number that what you go by to see, okay, how significant. Because if I had a number that was like 0.04, pretend that my calculated p-value was 0.04. Then if I ask you, what was the result, was the difference statistically significant? Then you're gonna go, I don't know, it depends. If you are being more lenient and you're using the 0.05, then yes, because this is lower than 0.05. But if I'm being more stringent, I'm lowering my limbo bar, then this number didn't pass under it, didn't make the cut. So this would not be statistically significant if my critical p-value had been 0.01. All right, so one more thing before we take a break. This number here is the p-value for the f-test, which is looking at, was there a statistical difference between the variances? But maybe you want to know between the averages. So then that's when we do the t-test. If you remember, the reason why I had to take a pause here is because I didn't know if the variance inside of this treatment was statistically different from the variance inside of this group. But now I know that the variance is not statistically different. And now I can go back to my t-test and I can enter my fourth argument. So let's remember this. First argument, the data for the first group. Second argument, data for the second group. Third argument, number of tails, which we're going to assume it's 2 tails. Last argument, you're like, oh, I don't remember the numbers. That's okay. We push this question mark and it says type, specifies the type. I still don't know the numbers. So you put learn more. And here it will tell you type. You type number 1 if it's paired. I told you I never type in paired in our experiment for what we did, because the data were taken from different petri dishes, not the same subject. You type a number 2 if there are equal variances. And you type a number 3 if the variances are unequal. So let's pause here. Remember, we concluded that there is no significant difference between the variances. So what do you think? Should we type for the t-test in here on the last argument? Are we going to type 2 or 3? Here, okay, good. All right, so Tasneem thinks it's 2. What do you guys think? So 2 is for equal variance. And I'll go like, okay, we concluded there is no significant difference. So if 2 things are not significantly different, then we're going to say that they are equal. So I'd say Tasneem is right. So we type 2 here. Good job. Thanks for participating. And then, ta-da! He gave me some number. What's the number called? It's called almost 19%. Okay, this number is the p-value of the t-test. So this is the probability that the differences I see between the averages of these and these are significantly different. So, okay, I'm going to ask the question here. Is there a statistical difference between the averages? Because we're doing a t-test between female and male shoe sizes. Then you're like, okay, this is my calculated p-value. And I compare that to a critical p-value. We are using a critical p-value of 0.05. So you have to see which one is larger. And basically, we're just checking if this number is equal or larger than this, then there's no statistical difference. If this number is smaller than our critical p-value, then there is statistical difference. So what's the answer here? Is that a yes or a no? Or maybe I'll just enter here. So this answer here, this would be no. Even though it's kind of shocking, right? Because these do seem like they are consistently larger than these. But it could be because this weirdo number here really drove the population, this average up. And then you could say, oh, what if we excluded Dr.T because it's not possible she wears something like that? You could exclude that and just to see what happens. So let's see, let's exclude me. And so the females would be until C5. So now, ooh, look at that. Now this number here became statistically different, right? 0.04 is lower than 0.05. Then over here, we would have to change this number to 3. And I'm still excluding myself. So C6 was me. So let's exclude me. Then I hit enter. Okay, still no statistical difference between men and women, even if you're comparing the 6.5s and 7.5s and 7 to the 10 and 13s. That's kind of surprising, but that's how statistics go.